All of us are fascinated by high-speed electric cars. Do you know what makes these cars attain such a high speed? These cars are powered by electric motors which allow them to attain such high speeds. Can you think of some more applications of electric motors? Not just in cars, electric motors are used to run devices like electric fans, water lifting pumps, and many more. Now a question arises. What is inside the electric motor which can run so many devices? Let's study its construction. First of all, two magnets arranged in such a way that the direction of magnetic field is from North Pole N of one magnet towards the South Pole S of the other magnet. A rectangular coil is placed between the two magnets in such a way that the plane of the coil is parallel to the direction of magnetic field lines. For our convenience, let's name this coil as ABCD. The two free ends of the coil is connected to the two halves of a split ring commutator. Let's call them as P and Q. The two split rings are mounted on an axle about which they rotate. To connect the commutator to the external circuit, we will use two stationary carbon brushes. These brushes are connected to a power source such as a battery via a key. Let's name these brushes as X and Y. So far, we have seen how an electric motor is constructed. But it will be more interesting when we understand how this assembly works. Close the key connected to the circuit. What did you see? The loop starts rotating in anti-clockwise direction. Now the question arises, why does the loop rotate in anti-clockwise direction? Let's find out. As soon as the key is closed, electric current starts flowing in the loop. The current in the arms BC and DA of the loop is either parallel or anti-parallel to the direction of the magnetic field, so they do not experience any force. Whereas current in the arms AB and CD is perpendicular to the direction of the magnetic field, so they will experience a force. Now one more question arises. How is the direction of the force in the arms determined? Does there exist any rule to find out the direction of force? Yes, of course. Fleming's left-hand rule. According to this rule, if we stretch the first finger of left hand in the direction of magnetic field and middle finger in the direction of current, then the thumb will point in the direction of force. All the three must be mutually perpendicular to each other. Let's apply this rule in the arm AB. For this, stretch the first finger of the left hand in the direction of magnetic field and adjust the hand in such a way that middle finger points in the direction of current, then thumb will show the direction of force. As a result, the arm AB will move downwards. Let us now apply this rule on arm CD. As current is flowing from C to D, it experiences a force in the upward direction. Due to these two forces, coil experiences a torque and it starts to rotate in anti-clockwise direction. As the coil starts rotating, currents in the arms BC and DA are not parallel or anti-parallel to the direction of magnetic field, so they will experience a force. But as both the forces are equal and opposite and acting along the same line of action, their net force is zero. Think of the situation when the coil rotates by an angle of 90 degrees. The contact between the brushes and the split rings is lost. As current stops to flow in the loop, they should not experience any force. Then what will happen? Will the loop come to a halt? No. Due to rotational inertia, the coil continues to rotate little further and contact is established once again. Current again starts to flow and loop continues to rotate in same anti-clockwise direction. Once the coil rotates by an angle of 180 degrees, split ring Q comes in contact with X and split ring P comes in contact with Y. Due to this change in connections, the direction of current in the coil gets reversed. As the direction of current reverses, the arm CD experiences a force in the downward direction and arm AB experiences a force in upward direction. Due to these two forces, coil continues to rotate in the same anti-clockwise direction. Once the coil rotates by an angle of 270 degrees, the brushes once again lose contact with the split ring. But again, due to rotational inertia, the coil continues to rotate in anti-clockwise direction until it completes one full rotation of 360 degrees. This process keeps repeating. For commercial purposes, to enhance the power of electric motors, electromagnets are used instead of permanent magnets. It also uses large number of turns of a conducting wire wound over a soft iron core known as armature.